Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Farid Ifzal bin Abdul Halim from Group KA36, and I will start our presentation about a comparative study on the consolidation of traditional and non-traditional stabilized peat. So for the first chapter, background study. So what is peat? Peat can be defined as brown deposit resembling soil formed by the partial decomposition of vegetable in acidic condition. Some of the physical properties of peat is highly organic, diverse in mixture, in anaerobic in low temperature. Besides, this type of soil is easily found in around the world, including our country Malaysia and especially in Johor. This type of soil is inefficient to resist load and have low strength. It also have high settlement because it has high compressibility and high fiber content.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Akademi bin Ismail and I will tell you about the problem statements. Peat soils are considered as extremely soft and wet. It is less efficient during the constructions due to the high settlements. It is unsuitable for the construction such as roads, building and others. There are many problems occurs caused by the high settlement of peat that can lead to the accidents and endanger the people's safety. To overcome this problem, the stabilizer are used to stabilize the peat and to improve the properties of the peat.
Bismillahirrahmanirrahim. My name is Muhammad Faizi Nizam, and my turn now to elaborate the aim and objective of this research. First, this study aimed to analyze the comparative or the consolidation test of traditional and non-traditional stabilized peat. There are three main objectives in this project. A. To identify the settlement of original peat. To observe the effect of different type of peat stabilizer or the settlement properties. To measure the coefficient of consolidation in original and stabilizer peat.
Okay, next is for the scope and limitation. Firstly, we gather the data and sample of the peat at the Parit Nipah Johor. The test we conducted is odometer test. The stabilizer used a vinyl acetate acrylic copolymer VAAC as a polymer and cements. So the sample is original peat, peat with polymer and peat with cement. The test will take 7 to 14 days for the curing process.
Now, I would like to elaborate the organization of thesis. Chapter 1, we will identify the problem area and collect the data before we start research. And in Chapter 2, we will visit the scene, the place or study of peat soil, bringing a sample such as a thesis in the lab, University Tun Hussein Am. In Chapter 3, we will provide the sample using the consolidation process. We will use duration 40 hours, 24, 12, and multiply a load to 25, 50, 100 until 800. This is hypothesis first. And Chapter 4 is we get the data from odometer test and we result it will compare with traditional and non-traditional stabilizer peat material. Last but not least, Chapter 5, we will collect the data and compile and cut to the procedure of certificate journal, writing as well as guideline from lecturer.
Classification of peat. Classification of peat has been established as a consequence of various given criteria. Different classification of peat evolve at the different area. For the classification method, soil is separated into organic clay, marsh, and peat. The method based on the peat thickness, which is shallow, moderate, deep, and very deep. Soil Taxonomy 11 edition USDA and World Reference Base for Soil Resource WRB is the international scheme for the classification of peat. Unfortunately, this system cannot be used to classify tropical peat in Malaysia. So, Malaysia classification system has been invented by Pramanatan by modifying the USDA system to suit peat in Malaysia. This classification highlighted the wood content and the peat depth. The diagram shows the structural arrangement of peat that contain fiber and soil particle. Fiber are found in the soil, especially for the peaty soil. The peat is classified as the fibrate peat due to the high fiber content, which is 65%. The fiber content can cause settlement in peat. The increasing of the fiber content can increasing the settlement of the peat itself.
Okay, now consolidation of peat. Consolidation refers back to the mechanical method through which is soil adjustment extend regularly in react to the external in stress. This takes place due to the fact the soil in a two-section material, comprising soil grade and pore fluid and generally groundwater. There are three types of consolidation. First, immediately deformation, primary and secondary consolidation. Primary consolidation is defined as a process in which the amount of soil decreases. This also defines the decrease in the content of saturated soil water in ocean without water replacement with air. Primary consolidation treats consolidation only in one dimension. This is a formula for primary consolidation. We have used final vertical stress and internal vertical stress and internal vert ratio. After that, we continue to secondary consolidation. Secondary merging happen after number one compression, despite the fact that extra hydrostatic strain happen despite a venturi of placement arise with inside the soil after number one consolidation are called secondary compression and are commonly time dependent. This is a formula for secondary consolidation, and we also using for this method.
So for the next subtopic, I can explain about the peat stabilization. So what is peat stabilization? It can be defined as a process to stabilize or make something physically secure. So the something is indicated to the peat soil. It can make alteration to the negative geotechnical data, which means it will become more durable for the engineering works. There are two types of stabilizer that will be used. There are traditional and non-traditional stabilizers. So for the first one, traditional stabilizer is one of the traditional methods that have been used for such a long time. Example for the traditional stabilizer is cement. It is made up of tricalcium silicate, dicalcium, and solid solution described as tetracalcium ferrite, and lastly tricalcium. Why this type of stabilizer become famous among the engineers? Because it is easy to find and readily available. Because the cement is easy to find, we can find it at the manufacturer factory. So the result after we have used the cement as the stabilizer, it will produce a good with high compressive strength of soil, and it will become suitable for engineering works. The second type of stabilizers is non-traditional stabilizers. This type of stabilizers is chemical formulated stabilizer, which compound is slightly different from the traditional one. This type is more preferable these days among the contractors and engineers. This type of stabilizer are categorized to a few groups, such as salts, enzymes, and acids. The advantage of using these stabilizers is it can shorten the curing time. So when we can shorten the curing time, the cost or the budget for the certain project can be reduced. And lastly, the most used non-traditional stabilizers is polymer. So for the methodology, chapter 3. For the first one, sampling process. So for the sampling process, we will take soil from the certain site, and we'll dig the soil with a hole for 0.3 meter from the topsoil. We will not take the topsoil because the topsoil is likely to be exposed to surrounding, and it will become not raw soil. So then the impurities from the soil will be discharged. Some of the impurities, such as roots and stone, will be discharged to ease the sample formation process. So after that, we will conduct one post classification to classify the peat. Then there are two types of sample that we will make. The first one, original, which is raw peat soil without any additive or without any stabilizers. The second one is stabilized. The stabilized sample will be added with stabilizer, either traditional or non-traditional, which is cement or polymer.
Okay, this is method to determine the basic properties of peat. Okay, first is moisture content. The test method is to determine the moisture content of soil by drying with direct heat. During this test, the mass of moist sample and the dry sample is calculated. The difference between the mass of moist sample and the dry sample is used as the mass of water content in the sample. The percentage of water content can be calculated by dividing the mass of water by dry mass of the soil and multiple with 100. The formula to calculate the water content are shown in the slide. Okay, next is for the liquid limit. Cone penetrometer test is used to define the liquid limit of the soil. During the test, the cone penetration value is measured. Each cone penetration is plotted as ordinates against the corresponding moisture content as Albiskisa. The best straight line fitting this point is drawn. From the graph, the moisture content corresponding to a cone penetration of 20 mm is read off to the nearest 0.1%. So the narrow hole ratio here identified as the liquid limit of the sample.
So, establish mix ratio. This step is one of the crucial steps in doing this test. This step will be used to find the ideal ratio between the additive and the sample. The densification is when the compaction removes the water from the soil and slightly change its structural arrangement of the peat. So, one of the way to find the ideal ratio is by run the Proctor test. The aim of this test is to identify ideal moisture content of certain soil that likely will become denser and obtain maximum dry density. There are two parameters that will be involved in this test, which are moisture content and dry density of soil. So a few apparatus that will be used, such as cylindrical metal mount, metal rammer measuring cylinder, 20 mm sieve, and large metal tray, drying oven, electronic balance, jacking apparatus, and small tools to help the test. So, a few steps of the test is the peat soil will be compact into a cylindrical mold with a specific dimension of height and diameter. It will be added layer by layer to make the soil will be evenly scattered around the cylinder, so it will get an accurate result. So the peak point will become its maximum dry density. This and the corresponding of it will become the optimum moisture content. Then this test will be repeated using various soil and various moisture content.
Okay, mixing process. The mixing process will be conducted at the optimum moisture content and maximum dry density of the sample. The stabilizer used is cement and BAAC. The peat and the cement are mixed in the mixture for 3 to 5 minutes to the sample mix well, and then take out the sample from the mixture and let it for 1 hour to the sample to distribute well. And then the procedure is repeated using the VAAC. The stabilized sample are curing at the room temperature for the 14 days.
Assalamualaikum warahmatullahi wabarakatuh. Sampling formation. Sample formation we do after mixing process. There are 3 classification that we use. For example, first natural, second stabilizer first, and third second stabilizer. The natural is original peat. We not mix with other material, and peat VAC for stabilizer one. This is there's volume of 70% VAC, and lastly we mix to this sample with cement. The force we'll use for each of sample to determine the moisture content. After that, specimen will observe in for 24 hours for each load. Before we prepare the apparatus, we can try to use the load in this test. First, we place the free container and in the container. Use level adjuster to make horizontal and vertical measure. After setting the controller, the specimen vertical and horizontal, we make sure we relaxing the soil before we starting. When the load arm horizontal lock, the screw vertical, then add the required load lead to the hanger. Yeah. This show the apparatus consolidation. The beam support jet white hang white. White will change when we have a data. For example, when we use 5 kilonewton, kilo per mile Pascal, we change at weight, the place weight in 24 hours. After that, we get the data, we change another. For example, 10. after we get the data, change until we get the final data, for example 360. Same unit width is called 0.25, 0.5, 1, 2, 4, 8 and 18 for the experiment.
So what we can expect from the test, the stabilized sample will have more strength and low settlement after the test. Then the sample with the non-traditional stabilizer will act better than the traditional stabilizer.
In the conclusion, based on chapter 1, 2 and 3 on this project, we are capable of get a few information about the geotechnic course, and we can also discover a suitable technique to run the tick and look at for our project for the past research. For chapter 1, we are able to decide the goal and the info so one can be had to run this mission. For example, scope and the problem and additional of comparison of this thesis. For chapter 2, we can advantage more knowledge about the properties of peat of soil and also the perfect technique to run this project. For example, suitable technique to do sample information on stabilizer peat and mixing process. From chapter 3, we control to decide the technique this is suitable to run the test for this mission, that the direct consolidation test and the usage of the odometer test. That's all from us. Thank you.